Okay, so I'm going to show a video on how to solve for greatest common factor and least common multiple. So I'm going to look at our in-class sheet from the other day. So here I have our question. Your local radio station is giving away their yearly music player and concert ticket giveaway. For 1 minute, every 5th caller will win a music player and every 7th caller will win concert tickets. You were just the first caller to win both a music player and concert tickets. What number caller were you? So I'm looking for two numbers, 5 and 7, to have the same multiple, okay, at the same time. So you're the first person. So we are looking for least common multiple, okay? So here I have, for 1 minute, every 5th caller will win a music player. So here I have a music player that happens every 5 minutes, or the 5th caller, and concert tickets happens every 7th caller. So I'm going to list out their multiples to see, okay, here's the 5th caller, then the 10th caller, then the 15th, but I want them to happen at the same time because you win both of them, okay? So I have 5, 10, 15. I'm going to catch up with my 7. So 7, 14, okay? I can go back up here. 5, 10, 15, 20. 7 times 3 would be 21. Keep going because they don't match yet. Okay, 25, 28, 30, 35, 35. So here, I know that I am the 35th caller, okay? Because for every 5, you win a music player. Every 7, you win concert tickets. So to win both, you have to be the 35th caller. So that's least common multiple. Now, greatest common factor would be a situation like this. Shakira is baking cookies to put in packages for a fundraiser. Shakira has made 84 chocolate chip cookies and 63 sugar cookies. Shakira wants to create identical packages of cookies to sell, and she must use all of the cookies. What is the greatest number of identical packages that Shakira can make? So here it clues me in, greatest number of identical packages. That's what we're looking for when we are finding greatest common factor. The greatest amount of equivalent groups, okay? Equivalent means same, identical. All right, so what I do, I have my chocolate chip cookies and I have my sugar cookies. Oops. So I have 84 chocolate chip cookies and 63 sugar cookies. So I start by thinking, okay, what are these numbers both divisible by? All right, well, I know that if I add the two numbers together, the two digits in a number, if I add them together and if those are divisible by 3, then I can divide the number by 3. So 8 plus 4 is 12, and 12 is divisible by 3. And 6 plus 3 is 9. So 9 is divisible by 3. So I know both of these numbers can be divided by 3. So I'm going to start there. So I factor out the 3, which means I pull it out. I divide it out. Okay? 3 goes into 8 2 times with 2 left over. 3 goes into 24 then. I'm just doing long division in my head like this. 3 goes into 8 2 times. 6, so it has 2 left over. 3 goes into 24 8 times. So I know this is 28. And then here, 3 goes into 63. 3 goes into 6 2 times. 3 goes into 3 1 time. So now I have 28 and 21. So I have to think, do those have a common factor? Yes, they do. They can both be divided by 7. So I factor out the 7. 28 divided by 7 is 4. 21 divided by 7 is 3. Okay? Now 4 and 3 are not divisible by the same number anymore. They do not have a common factor, so I know I've reached the end of my problem. So since I have more than one number on the outside, I multiply them. 3 times 7 is 21. So I know that she has 21 packages. But now I want to see, okay, what's in each group? I know the question doesn't ask for it, but sometimes they do. So I look at my last row, and I see, okay, 4 lines up with my chocolate chip cookies. So I have 21 packages with 4 chocolate chip cookies and 3 sugar cookies. And that's how I solve for greatest common factor.